All right, guys. Good afternoon. But can see the screen online. Online students can see the screen. Zach Merchant. Kwame.
Sir.
Can you see the screen?
Yes, sir.
Yes, sir.
All right, good. All right, good afternoon, everybody. So, when I work through this paper, what don't turn on the projector yet? Couldn't tell me. Hold on a second. All right, let's do this. Another day. Then we have another mock exam Wednesday and Thursday. We have mock exam Wednesday. We have mock exam Thursday. We have 2 mock exams on Saturday. More maths equals better maths every time. All right, so this is the June 2021 paper. Actually, it was done in July, because this was the year after COVID. All right, so we're going to work through this paper. And we have to move the pass mark from next week. So you all have to improve. You have to get better. All right, hold on a second. Improve. Moving the pass mark. Moving the pass mark from next week. Okay. All right. So again, remember, I'm not teaching now. Basically, I was working out the questions. And we're doing it in a way that should mirror what you would do in an exam room. So what I'm doing here is basically what you would want to do in an exam room to get your marks. You don't have to be exactly like I do it, but generally speaking, it's a good guide. Let's do it. Nobody start talking. Class just start. Why you wait the class start for people? Why you never ask before the class start? Huh? And then time I pick on you now, you say me pick on you. And you cause it. All right, let's go. First question. Always is a calculator question. But I want us to use a calculator to work this out. So again, it's just basically typing this in the calculator exactly as it appears there. Put it in the calculator. So starting out with a mixed number of 1 and 4/7. Then we're dividing by a number, a fraction, 2/3. And then we are subtracting a mixed number of 1 and 5/7. And as a fraction, this is the answer. 9/14. 9/14. That's what this is equal to. Argument done. Good. First mark. Actually given 2 marks for that. Can you believe it? Next question. It says, when Megan started working, she was paid $85 per week. It says after a 6 months probationary period, that's when they are testing to see if she's suitable for the work or not, for the job, her pay was increased by 20%. So she's now earning 120% of what she was before. How much was she paid after the increase? She was now being paid 120%. You don't have to calculate 20% first and then add it. You can just calculate 120% times the amount that she was earning, which is $85. And that is the new amount that she's earning. 120%, not 125, 120. There's 120% times 85. That's $102. She's now earning $102 per week, each week. So we can write per week right here. Make sure it's per week they want it. Argument done. 1 mark for that. We want the 1 mark. Next question. Next question says, in 1965, the population of country A was this, 2,714,000. In 2015, which is a whole of years that later, the population grew to this, 3,663,900. It says, write the population in 2015 in 3 digits. That's this one. They wanted to 3 digits. All right, so let's look at it. 3 significant figures, not 3 digits, 3 significant figures. So it's 3,663,900. Remember, the size of the number cannot change. It's 3.6 million. The final result must be still 3.6 million. Them size a number. All right, we're correcting it to 3 figures, 3 significant figures. These are the first 3 figures right there. All right, and this 3 cannot increase that, cannot. So you're starting back then with the 366. But then all these position zeros there. So the number was in the 3 million, 3.6 million range. The answer must still be in that range. That's it. That is 3 digits. That is the answer. You can't write 366. There's no way you can replace 3.something million and put it as 366. Can't make no sense. It must make sense. It's just like if you're going to buy something and something costs say 10,351. 10,351. And somebody asks for it. You might just say 10,000, or if it costs 10,851. Somebody might just say, walk with 11,000. Then now I'll tell you to walk with $11. Okay, giving it to 2 significant figures. All right? That is it. All right. So this one now says, write the population in 1965 in standard form. So what is the number we're talking about? This number. We want it in standard form. 2714000. We need the decimal point to be right here when it is in standard form. There's no decimal point showing the number. It is like the decimal point is right here at the end. So how many places we have to move it back? Remember, this is a large number, you know? So when you finish, it must be 10 to some positive number. That's a large number. All right? So how many places have to move the decimal point to get it here? 1, 2, 3, 4, 5, 6. All right. So therefore, the final answer is going to be 2.714 times 10 to the positive 6. Because this time 10 to the positive 6 now, you don't have to put on these zeros. I can leave them off. Because with the decimal point here now, the 0, 0, 0 here becomes immaterial. So I don't have to put them. So basically that is it. All right. This time 10 to the 6 now would, if the decimal point is now here, this time 10 to the 6 would move it back to the end. Basically that's it. The size of the number stays the same. All right, next one. He said determine the percentage increase from 1996 to 2050, the percentage increase in the population. So it is the increase over the original amount as a percentage multiplied by 100. So you want the increase. The increase is the difference. So therefore, just working it out, it is 3663,900 minus the original amount, which was 2714,000. That is the increase divided by the original amount, 2714,000, and they multiply that by 100 to get it as a percentage. That's what they're doing. This is the increase. I don't have to calculate the increase and put it on one side. I don't need to do that. Just do one calculation and write the answer. So I'm just going to put that in the calculator now, like that. So the increase is 3663900 minus 2714000. That's the increase there. I don't have to see what the actual increase is to work it out. Divided by the original amount that is increasing on, which is 2714123. And then all you have to do is multiply that by 100. But 0.35 is 100, but it's 35%. Right? But if you want to show it as a percent, you multiply by 100, it's 35%. So it's a 35% increase. I don't need to actually see what the actual value of the increase is. If you put it, no problem, but this is good. All right, let's move on. Next question. It says the ratio of teachers to male students to female students in a school is this. Teachers to male to female, that is the ratio. It said the total number of students in the school is 630. Determine the number of teachers in the school. Determine the number of teachers in the school. So I like to do the ratio the simple way, where you just multiply it by values or divide it by values to get what you want. So let's set up like this. Teachers to male to female, they gave us that as 3 to 17 to 18. But because they are telling me about the total number of students, I'm going to add in a section for the students on this ratio. I'm going to extend this ratio and add in a section. Let me put it on in purple. I'm adding a section to this ratio. I'm adding another part of the ratio, which represents now the students, S. And it will be represented by the sum of these two numbers, and that is male and female. What is 17 plus 18? How much? 35. So when the two actual numbers broken down in a ratio form, these are the values. But the actual for the students is 630. So therefore, I would want this side to become 630. If I'm going to show what the actuals are, I want this to become 630. So the question is, what am I multiplying that now by for it to become 630? And then all you have to do now is multiply the rest of the ratio by that same number, and you would have the actuals. Right? So therefore, we're going to see what we multiply by, which is a 630 divided by 35. These are multiplied by 18. So we have to multiply the ratio by 18 to see what the actual numbers are. They want to know the number of teachers. So this we really need to multiply by 18. I don't need to work out these. I'm not interested in those. I just need to multiply the number of teachers, which is 3 by 18 as well. And that will tell me what the actual number of teachers are. So this becomes 3 times 18, which is how much? 54. This becomes 54. So when the total number of students is 630, the total number of teachers is 64. Can I write this? Number of teachers is 54. And that is it. That's my answer. If they wanted the number of male students, but I've multiplied this by the same 80. They wanted the number of female students, I've multiplied this by 80. But they don't need that information. It's really the teachers are focusing on. So let's multiply that by 18 over here as well. Right? Let me put it over here. Multiply this also by 18. And that's a simple way to the ratio question. Multiply to get the actual information. Find what number you need to multiply the ratio by to get the actual information. And it is also a good skill to know that you can add a section to the ratio based on the information you're working with. Sometimes they could have maybe said the difference between the number of boys and girls. You could have said that as well, you know, give you information about the difference. So you're adding a part to the ratio for the difference. Stuff like that you can do to make the question easy. All right? 9 marks that. Easy 9 marks. The target now is only 30. All right, let's continue. This equals 30, right? That was 35. What was it? 35 or 30? 35. All right, so next week we're going up to what? 40 or 45. I need to look back at it. But you have to improve, guys. You have to improve. All right, I don't need this anymore. In order for the targets, in order for you to move with the target, you have to improve. You have to learn from your mistakes. You can't be stuck at the same place. All right, this question now says, two quantities n and t are related by this formula. All right, it says, find n when the t equals 49. So we're taking the 49 and we're placing the t inside there. So clearly the n is equal to the square root of 49. And everybody knows that that is 7. Done. All right, next question. It says make t the subject. So we had n equals the square root of t. Easy now, want to make t the subject. I need to get rid of that square root. Inverse of square root is to square. So like I square this side and square that side. And the square root will be eliminated by the square. But I don't have to show all those markings. I just know that I need to square both sides to get rid of the square root sign. So I get n squared equals t. That is it, you know. T equals n squared. This is the answer right here. Easy as that. Make t the subject. So t equals n squared. What an easy question. Next part says, and I ask question like this in PEP. Yeah, they ask question like this in PEP. It says Ali is X years. That's her age. Jim is 5 years older than Ali. All right, so for Jim is going to be X plus 5, 5 years older. It says, and Chris is twice as old as Ali. So therefore, Chris is 2X. It says, write expressions in terms of X for Jim's and others. So the same thing that I wrote up here is what I want here. So now, all right, good. So therefore, Jim's age is what I have here, X plus 5. And Ali's age is twice, Chrissy's age is twice Ali's age, so this is 2X. Easy like that. All right, 1 mark for each of those. All right, let's take this off now. Next part says, in 2 years. So in 2 years, this person is going to be X plus 7. And this person is going to be 2X plus 2 in 2 years. In 2 years, Ali's age, the product of Ali's age. So look what they're saying now. The product of Ali's age, and Ali's age is this. The product of Ali's age. So in 2 years, Ali now is going to be X plus 2. So in 2 years, Ali's age is going to be X plus 2. Let's write that. Chris's age is going to be 2 on this. It's going to be 2X, and you add 2 to it. Will be the same as the square of Jim's age. No, this is Jim's age. No. Jim is going to be 2 years more than, no, present age. And Jim's present age is this. But I want the square of it. So that is X plus 5 squared. So this equals that. So that's what they say. The product in 2 years, the product of Ali's age. In 2 years, Ali is going to be X plus 2. and Chris's age, Chris is going to be 2x plus 2, will be the same as, meaning equal to the square of Jim's present age. Jim's present age is x plus 5. So the question basically that this is going to be equal to that. So let's write it out. So it means that x plus 2 times 2x plus 2 is going to be equal to x plus 5 squared. And I'm going to show this equation inside us. So all we have to do now is simplify this down, and it's supposed to work out to this. I'm going to expand this side first. X times the x is 2, x times the 2x is 2x squared. And then the middle term is the far product and the near product. The near product is 4x and the far product is 2x. You must know that. Inside here, the near product is 4x and the far product is 2x. That gives you the middle term. That is 6x. 4x and 2x is 6x. And the third term is this times this, which is 4. Equals, we're expanding this now, a perfect square. First term squared is x squared. The middle term is twice the product of the two. When you expand a perfect square, you get a middle term which is twice the product of the two. What you do twice the product of the two? Multiply these two things in here first, you get 5x, and then you double that to 10x. Then the second term squared is 25. If you never expand this right and get this, you have to learn from it now. When you expand a perfect square, you get 3 terms. First term squared, twice the product of the 2, second term squared. How do I get this middle term? I multiply these two things, the x and the 5. And I get positive 5x, and then I double it. That's how we get the middle term. Do all of this already. All right? Then all I need to do is transpose everything over here and leave 0 on the right side. So see here, this x squared, come over and subtract from 2x squared, give me x squared. This is 6x. I'm going to subtract 10x over here. 6 minus 10 is negative 4, so I'm getting minus 4x. This is 4. I'm going to subtract 25 over here. 4 minus 25 is negative 21, and I'm left with 0 on that side. Everything gone. See, same thing that I have right there, shown. If you never get it, go and do it over. You go and you do it over. Not go and watch over the video. Go and do it. All right, that done. Next question. It says calculate Ali's present age. In other words, they want us to calculate x. That's what that means. They're trying to ask, they're asking for x. So to find x, we just need to solve that equation. So we're going to start by saying x squared minus 4x minus 21 equals 0. This is easy to factorize because you know that the factors of that is only x and x. You have to learn to do it the easy way, guys. You have to learn to do it the easy way. They want factors of this negative 21 or factors of 21 where the difference is 4. Factors of 21 where the difference is 4. That must be 3 and 7. So you want 3 and 7. And this says that the two signs in the bracket are different. This tells you that the larger one is negative. The larger product. What's product? I'm talking about the far product and the near product. The larger one must be negative because the middle term is negative. The larger one is the 7x here. The near one is 3x. You have to make the larger one negative, which is the 7x. To make the 7x negative, I put the minus here and the plus there. Those are the factors. You have to learn it this way. If you want to do the long drawn out way, no problem. But you have to learn the quick way, especially when you have factors like these, where you do only that alone can go there. And you know, it's factors of this that's going here and here. You have to learn it that way. Then this is giving me x equals negative 3. This is giving me x equals 7. I cannot act negative 3. Negative 3. This gives me x equals negative 3. But understand that? Good? Because remember, is that this equals 0, which means that the x is going to be negative 3, or this equals 0, which means that the x is going to be 7. But you cannot accept a negative age. Somebody age can't negative. So this one is not valid. We're talking about the age of somebody. So this answer is not valid. And therefore, this is the answer. Ali's age. That is the answer. That is Ali's age. 7. She's 7 years old. Can't give somebody age negative. They cannot accept this as an answer. So Ali's present age is 7 years. So we're gonna write 7 years on it, yeah? Because them say our present year age, let's just write 7 years. Our present age is 7 years. Done. Number 2 done. 18 marks so far. Let's continue. Number 3. Trigonometry. Right angle triangle, easy. So-called tower, Pythagoras theorem. So-called tower, Pythagoras theorem, because that's a right angle triangle. All right. Diagram below shows triangle PQR in which QPR is 62 degrees. This angle is 62 degrees. Remember, these two angles are complementary. They add up to 90 degrees. Them two angles, they add up to 90 degrees. Because this one is already 90. All right. Question says an angle PQR is 90, and then this is the hypotenuse. That is the hypotenuse. One is the hypotenuse because it is opposite the 90. Not just that it is the longest side. I don't like that definition. Prefer the definition that says it is the side opposite the 90 degrees is the hypotenuse. But sometimes you get some diagrams where the sides are so close in length, you might pick the wrong one as a hypotenuse if you're going for just the longest side. I don't want that definition. I prefer you say it is a side that is opposite the 90 degrees is the hypotenuse. All right? So that's the hypotenuse. So we're going to be using so-called tower on this. First question is first to calculate angle PRQ. This angle right here, easy. It is 90 minus 62. This angle equals 90 degrees minus 62 degrees. Them two angles here must add up to 90. They are complementary angle. How much is that? How much is that? 28 degrees. Don't it? I'm going to put it on the diagram same time. This is 28 degrees. Next question. The length of RQ. Length of RQ, which is now this side. So we can calculate the length of RQ using so-called tower. We have to use one that has a hypotenuse in it. So it's either cos or tan. Cos or sine we're going to be using. It all depends on which angle you're going to use. So if you're using 62 degrees, then this side over here is the opposite. If you're using 62 degrees as the reference angle. If you're using 28 degrees, then this is the adjacent. You can use either one. So I'm going to do it both ways just for you today. So if I'm using the 22 degrees, the 25 degrees as my reference, then I'm going to be using adjacent over hypotenuse, which is cos, so-called tower. All right, so I can say the cos of 28 degrees equal the adjacent side RQ over the hypotenuse of 11. And to get the RQ, multiply by 11. So RQ will be equal to 11 times the cos of 28 degrees. Or, you don't have to do it both ways, one or the other. All right, I'm just doing it to show you that you could have used any one. Or we can say sine of 62 degrees equal the opposite side. So for the 62 degrees now, the side that we want RQ will become the opposite side. Opposite will be 20, it will be RQ over 11. So to make RQ the subject, we would multiply this 11 up here. And so the RQ would become 11 times the sine of 62 degrees. I guarantee you that RQ is going to be the same, whichever one you use. Whether you use this one or use that one. Because the sine of 62 is equal to the cos of 28 because they are complementary angles. Sine of an angle is equal to the cosine of its complementary angle. What's the complementary angles? Angles that add up to 90 degrees. See it here, if I do 11 cos 28, I am getting 9.71 centimeters. And if I use the other one, which is 11 sine 62, get the exact same thing. So whichever one you use, you're going to get the same answer. So this is an OR method. You don't have to do both of them, one or the other. I'm just showing you. All right, what else I want us to do? Oh, that question done. Then we come now to this question here. It says the diagram below shows triangle X, Y, and Z. Let's look at them. This is the X1. This is the Y1. This is the Z1. Now, let me use the reading now. Reading shows a little bit clear on these diagrams. All right, so we have some transformation taking place here, right? You can actually look and see what transformations they are in. They're kind of straightforward. They're clear. This one says triangle X is mapped onto triangle Y by a reflection. State the equation of the mirror line. See, they want the equation of the mirror line. The equation of it. All right. So clearly from this to this, mirror line is halfway between them. So it must be this x-axis. So the reflection is the x-axis, but the marks for the equation. The equation of the x-axis is y equals 0. So you can't say the answer is the x-axis. No. X-axis is not an equation. So if you write x-axis, you're wrong. The answer is y equals 0, but you have to answer the question set. It asks for the equation of the mirror line. The mirror line is the x-axis. The equation of the x-axis is y equals 0. Everything important. So here we know that it is the x-axis. It was reflected in the x-axis. The equation of the x-axis is y equals 0. This is the answer. One mark for it, you know, so if you write this, then I'll get the mark. Now I get the mark. This way you have to write. Answer the question. All right, so don't put this in blue. Everything important. That's why the past paper. So see these things I will learn from these mistakes. Everything important. Next part says, describe fully the transformation which maps X onto Z. X onto Z. All right? Remember, when describing a transformation fully, you give the name and the components. You give the name of the transformation and the components of the transformation. So we're doing from this one to this one. That's pretty obvious. That's a rotation. It's actually 90 degrees. But this side, which was horizontal, that way, is now vertical. That way. So the rotation is this way. And it's 90 degrees. Go from horizontal to vertical. It's a 90-degree rotation. And that is anti-clockwise. Remember also that anti-clockwise rotation is positive rotation. I'm going to say it every time. So that in case I'm coming in the exam with no positive, negative, you remember. Anti-clockwise rotation is positive. Clockwise rotation is negative. So that's an anti-clockwise 90-degree rotation. But you're not finished yet. Because rotation must have a center. So you need to know where the center of the rotation is. Once you're describing a rotation, you have to also state the center. So the center of this rotation normally is the origin. You just want to double check and make sure it's the origin. Right? So, like for example, here, that's the origin. So if you check the points, so for example, this point here would have rotated 90 degrees down to this point here, which makes sense. So that shows that the origin is true. And if it's at this point out here, and all you can do it is form out the coordinates, like a L. From the origin, make like a L, like you're forming out what the coordinates would be. And like you're rotating those coordinates. So this X value would have rotated up here and become the Y value. So this length is 6. It would have come to 6 up here. And this piece at the top of it, which is 2, would have basically now be over here. So that's it. When you rotate this L, it takes this point to this point. So you do it to 2 points and it works for 2 points, you're good to go. You have confirmed that the center of rotation is the origin right here. So now we can write the description. It's an anti-clockwise 90-degree rotation about the origin. It's an anti-clockwise 90-degree rotation about the origin. So let's write it. An anti-clockwise 90-degree rotation about the origin. Origin is the point 0, 0. Let's make sure that we have everything. We have the name, rotation. Rotation has 3 components. Angle, we have the angle. Direction, we have the direction. And we also have the center. So you know, so you're good to go. Remember, guys, instead of saying anti-clockwise 90-degree rotation, we could have said a positive 90-degree rotation for the anti-clockwise. All right? Well, let's work with that. Done. Next part says down here. In the diagram on page 10, that's the same diagram with the triangles, right? Transform or translate, that's a translation I want to know. Triangle Y using this vector, negative 7, 1. Let's write down here what negative 7, 1 does. Negative 7, 1. This negative 7 is the horizontal movement that the point is going to go through. It means you're going to move the point 7 units to the left because it is negative. This one is the vertical movement that the point will go. On the y-axis, y direction movement, which is 1 unit up. So a point here would end up here, 1 unit up. So all we have to do is move the points 7 units to the left and 1 unit up on the triangle. Which triangle transforming? Transforming triangle Y. Translate triangle Y. I must label it V. It's Y they want us to transform, you know, triangle Y. 7 units to the left, 1 unit up. What you can do sometimes is move one of the points and then you draw about the same shape around that point instead of moving all 3. Because you know that when you move it, size not going to change, the orientation not going to change. You just change position. So 7 units to the left, 1 unit up. That's what this translation will be. Let's go and count it now. We're talking about triangle Y. All right, let's go. Triangle Y. Which one is triangle Y again? This one. So I'm going to start with this point. I'm going to move this point right here. 7 units to the left. It's easy to use that point because I know so from 0 on the y-axis, 7 units to the left, taking it over to negative 7 right here. So that point is coming here, so. That's where that point is going to go. And then common sense, you can fit in the rest. So that point is going there. So this length stays the same. This length, which is 5 units, see? No, 6 units. This length is 6 units. Stays 6 units. So you can literally draw about that 6 units line. So from here, 6 units, 1, 2, 3, 4, 5, 6. That's it. And then from here to come to here, what they do? You go down 2, go back 2. So I'm going to do from this point now is go down 2, go back 2. So this point is right here. And therefore, this is my image triangle. Simple as that. Do the mathematics the easy way. What am I supposed to? Yes? Huh? Oh, 1 up. Ah, thank you very much. I forgot the 1 up. All right. Thank you very much. All right. Mr. Atina, sharp like razor. All right, yes. 7 back, 1 up. I was so focused on the 7 back. So 7 back, 1 up. All right, thanks for that. 7 back, 1 up. So that is it. And you draw about the shape in it. All right, so next one now. Next one, oh, there's almost label it to a V. Label it V, right? All right, label it V. So we're going to label this one V. All right. Next one now says we have to do an enlargement. See, transform triangle X, center O, and an enlargement we're doing on it, and the scale factors are half. So the scale factors are half. The image is going to be half the size and half the distance from the center, which is the origin. All right. So like you're bringing the object halfway back to the origin. Because you're half in the distance and you're also half in the size. Or you can half the coordinates. You can also half the coordinates because the scale factors are half. Then the matrix will be half, 0, 0, half. That will be the enlargement matrix. And it will move a point xy over to half x, half y. So it's basically half in the coordinates because the center of the enlargement is the origin. That is why we can use that matrix, the enlargement matrix, K0, 0K. So we're doing it on what? Triangle X, right? Triangle X. We're doing it on triangle X. All right, so this is triangle X. So it's kind of easy because at this point, you're going to come halfway. See the center of this enlargement here, the origin right here. So this point, which is 2 away, is going to come 1. It's going to come to here. So this point will come to here. All right. This point, which is at 4, 4, half of 4, 4 is 2, 2. So it's coming to 2, 2 right here. That's this point. It's coming to 2, 2 right here. So the center of the enlargement there, so coming to 2, 2. So this point coming here. And then this point, which is what? 6, 2 is going to come to 3, 1. 3, 1, which is right here. If you half the coordinates. So if you throw it in, the construction line is like this. That whole distance is now cut in half right there. And so your triangle is this. Your image triangle is this. That's the enlarged triangle, but it really gets smaller, but still enlargement. It's enlarged by a scale factor per half. That's why it is now half. But them supposed to label that one. Half the size and half the distance. W. So label this one W. All right. That is that. All right. Good. Next question. That one done. All right. Next question. Coordinate geometry. I see they set in this question in section 2 from the other day. Coordinate geometry. I think in January they set a coordinate geometry like this in section 2. I think the paper before that was in section 2 as well. The first question in section 2. So that's what I've noticed. But anyway, wherever it is on the paper, we need to do it. All right? So the diagram below shows 2 lines, L1 and L2. The equation of L1 is this. So give us the equation of this line. And the short on the line as well. And the line L2 passes through this point. So this is the C value now. So for L2, you know, so the C value is -5 right here. All right? That's what it means. C value is -5 right there for L2. But them said perpendicular to L1. So these 2 lines perpendicular. So it means that the gradient of line 2 is equal to -1 over the gradient of line 1. You know that right away. That negative reciprocal gradients, right? All right. Let's see what I want us to do now. It says express line 1 in this form. So in other words, put it in the standard form. Make y alone the subject. Because when you do that, you are able to see the gradient and the y-axis intercept of line 1. So line 1 starts out with an equation x plus 2y equals 10. I need to transpose and leave that y alone as the subject. Move the x first, but I'm going to put it in front because I'm trying to get it to look like that. So it's 2y equals -x plus 10. Then to get rid of this 2, I can divide 2 by 2 or I can multiply 2 by half. But because I want it to look like this with separate values, I want it to look like this line equation with separate values, I'm going to instead multiply 2 by a half. When I multiply 2 by a half, this becomes y. This becomes -half x. -half x. You see, I'm able to see the m right now. It's -half. And when I multiply this by a half, I'm getting 5. So 5 is the y-axis intercept. So this line crosses the y-axis up here. So at 5, right? This is 5. All right? Well, let's continue. That's the first part. Next part says, state the gradient of line 1 now. See this, sir? Half. Just state it. Now, if you calculate nothing, gradient of line 1, I'm calling it M1 is equal to -1/2. And they will accept and they will understand they put M1 like that. I want to reference it back now for line 2 with this equation or that expression. All right? Next part now says, hence determine the equation of line 2. To find the equation of line 2, we need to know 2 things about it. A gradient and a point. Now remember, for line 2, we already have that the C for line 2 is equal to -5 for line 2. And we know that the gradient of line 2 is minus 1 over the gradient of line 1. The gradient of line 1, remember, is negative a half. So you can take the negative a half if you want and put it on a here, so. Or we can remember that this calculation is done quickly by flipping the one that we have and change the sign. So if you flip this negative a half, first it becomes negative 2, and then change the sign to a positive 2. So this is going to work out to a positive 2. Gradient of line 2 is a positive 2. If you want to calculate it, as I said, by putting negative half under here, you're going to still get the 2. But we have to learn to do mathematics the quick way still. And the quick way to get perpendicular gradient is to take the one that you have, flip it and change the sign. That's the gradient of the other line when they are perpendicular. And once you know the M and the C on a line, we can use Y equals MX plus C for that line. So for line 2 then, it's going to be Y equals the gradient of line 2 is 2, so that is 2x, and the plus C is negative 5. Negative 5. That becomes the equation of line 2. That's line 2 equation. Line 2 or L2. That's L2. L2 equation. The gradient and the y-axis intersect. That is it. Nice and easy. Let's continue. Next part is a functions question. Lovely. Question gives us these two functions, f and g. First part wants f of 9. So we're going to take 9 and put it in the f function right here. F of 9. So this works out to be a third 9 plus 4. A third of 9 is 3. 3 and 4 is 7. Beautiful. Easy. Next part wants f of g of negative 3. This is the same as f of g of negative 3. So we're going to work out the g of negative 3 first by putting the negative 3 in the g function here and there. We're going to work out that part first. All right? Much space to give to it. They say they don't give a lot of space. So it becomes f of 3 times negative 3 over negative 3 plus 1. So this becomes f of what? This is negative 9 over negative 2. Negative 9 over negative 2, the negatives cancel. We get 9 over 2, or you can put 4.5. So we can put f of 4.5. 9 over 2. If you want to write 9 over 2, no problem. All right, let's put 9 over 2. Then f of 9 over 2 now means that we're taking the 9 over 2 and putting it in the f function right there with x's. That's all it means now, right? So that's how we're going to get the final answer. So this then becomes a third of 9 over 2. Remember, see here is a third x plus 4. So it becomes a third of 9 over 2 plus 4. Plus 4. What is work out to now? This becomes 3 over 2 plus 4. This is 4 same as 8 over 2. That becomes 11 over 2. Gotta get that? 11 over 2. Correct? But this becomes 3 over 2. 3 over 2 plus 4. 4 is the same as 8 over 2. Yes, 11 over 2. So the answer is 11 over 2, or 5.5. Next part says, determine the value of x if g of x equals 5 over 2. So basically now I want to put this g of x equal 5 over 2. Let's write it. 3x minus x plus 2, x plus 1, putting that equal 5 over 2. That's what I mean by g of x equals 5 over 2. So we're solving this now. All right, so let's copy this down. That's what we want to solve. Let's copy it down. All right, so let's say it equal 5 over 2. Put it here. So it means that we're solving that. Because this is the g of x. Sorry. This is the g of x part right here. It's equal 5 over 2. So we're just basically going to cross multiply. Expand it out into separate terms. Bring the x on one side and solve. So we're going to multiply this up here and this up there. So multiply this 2 up here. So we're going to get 6x. Equal. Multiply this over here so by the 5. It's going to be 5 times the x. And 5 times the 1 is 5. So multiply this over here so by the 5. That's what we're going to get. Transpose this 5x over here and subtract it. We're going to get x. We're left with 5 right there. That's the answer. X equals 5. Nice and easy. X equals 5. Next question. Moving right along. Number 5. Flying through this one today. Number 5 says 100 students. This is important. 100. Total number of students is 100. You have to count everything important. So this must add up to 100 right here. So I don't want to forget it. I'm writing it there. We're surveyed on the amount of money they spent on data for their cell phones during a week. The table below shows the results as well as the midpoint for each interval. So they're helping you. They give you the midpoint value. Now remember, when the data is grouped, you can use the midpoint to represent the data. Because you don't know the actual amount spent by the students. Because you're saying 7 persons spend between $50 and $60. But you don't know if them actually, you don't know the actual amount that they spend. So because you don't know the actual amount they spend, sometimes you have to then to estimate stuff. Remember, when the data is grouped, you have to estimate. We're going to estimate that 7 of them spend $55, which is the midpoint value. And same thing for this group. 11 of them spend this midpoint amount of this group, which is 65. So that's why the midpoint becomes relevant, right? It says, using the table, determine the modal class for the amount spent. The modal class is the one with the highest frequency. See the highest frequency here? So this is the modal class. So we're going to write 70 less than x less than or equal to 80. I'm going to put the dollar sign around it, you know, because see it is in dollars. That's the modal class. The third class, the one with the highest frequency, is the modal class. All right. Next part says, calculate an estimate. You see, we can only estimate. Calculate an estimate of the mean amount spent, giving your answer to 2 decimal places. So to do that, we need a way to calculate the total amount spent by the 100 students. I was saying basically we are using the midpoint value to represent the group. So we need a sum column, which is a F times X, frequency times scores. We need a sum column, and the data is grouped. All right, because we're assuming that 7 persons spend $55 each. So you're multiplying that out. All right, let me bring up my calculator. I have to multiply each of these values now. Right here. So multiplying these values over here. This times this. Frequency times score. Times the midpoint values. So it's 7 times 55. 385. So it's 385. Total spent by those 7 persons is 385. Then 11 persons spend $65 each, approximately. So 11 times 65, that's 715. And then 31 persons spend $75. Now you could actually just multiply these and add them all up one time in the calculator. Right? But it's good to show some work for these, right? Where you get your values. So we're going to multiply these two now. 31 times 75. 31 times 75. That's 2325. And then 29 students spend $85 each. So that's 29 times 85. That's 2465. And then 22 students spend $95 each. So that's 22 times 95. That's 2090. And these are all approximate. I don't know the actual amount that they spent. I'm going to add up all of these now. This is the approximate total or the estimated total that all the students, all 100 students spent by adding this up now. So it's 385 plus 715 plus 2325 plus 2465 plus 2090. So we are saying that all 100 students spent a total of 7980, and this is in dollars. And it's 100 of them spend it. So the mean amount is this amount divided by the 100 students. So let's write it here. So I want to put that this is the sum of the sum, which is fx, over the number of students, which is the sum of f. This becomes 7980 over 100, which then is $79.80 is the average amount, the mean amount. The mean amount. Want to go to that? Want to go to that? All right, let's continue. Next part now says, Damien reported that the median, it's another question, like this the other day. Damien reported that the median amount spent is $84. Briefly explain why Damien's report could be correct. So if it is correct, it means that this 85 mean is in the group where the median, is in the group where the median should be. So if there are 100 students, the median amount is spent by approximately the 50th student. And the data is in ascending order. The data is in ascending order right here, so from lowest to highest value. And these are the students. So the ones who spend the low amount are in there. The ones who spend the high amounts are up here. You want to find the 50th student in this group. And which group the 50th student will be. So you have to add up these frequencies now. So we'd like checking up this frequency. So we would normally say, okay, put in a cumulative frequency column. I mean, that's a counting column. You're counting the student. You want to find the 50th student. Which group the 50th student is in. So we need a cumulative frequency. Cumulative frequency is counting up the students as you go from group to group. You want to see which group the 50th student is in. And the 50th student is the one approximately who spent the median amount. So you have 7 students first. They are the 11 students here. So 7 plus 11 makes so much? 18. You have to add this 31. How much are they going to get? 49. So the 50th student is in here. Because 49 down here, so you know. See that? So the 50th student is inside here, so we don't have to do anymore. The 50th student is inside here somewhere. The 50th student is one of these. See that? So the 50th student spend our money in between that and that. So that is what I'm gonna say. So I'm gonna leave these on my paper, on my paper, you know. These values that I put in. I'm actually leaving that on my paper and leave the 50th here, so I'm pointing this so I can reference it. So when I say, okay, the 50th student is in the 4th group. The 50th student is in the 4th group. So first we're going to say the median corresponds to the 50th student. The 50th student is in the 4th group, which is the 80 to 49. So I'm going to say that as my explanation. So something like that. All right. So when I say the median is approximately, so we're talking, approximately the amount spent by the 50th student who falls in the 80 is 80 to 90 in the 80 to 90 class interval. See there? 80 to 90 class interval. In the $80 to $90 interval. That's why it is correct. So $84 is in that interval. You can say that as well. $84 is in this interval. You don't have to use my exact words. Use your own words, but you must mean that. Use your own words, but it must mean that. And they ask this question other ways sometimes. Sometimes they say somebody estimate a value, and you must explain why their value is wrong. It's the same approach. You have to tell them which group the value is supposed to be in. You have to count up the students, count up the scores until you reach a middle score. Which group is the middle score in? And that's what I put in the counting column, which is our cumulative frequency column. The cumulative frequency column is that we have counting how many students you have as you go from group to group. So you can find where the 50th student would be. All right, that is it. Better go to that. All right, next question right here. It says the two-way contingency theory below gives information on the mode of transportation for the 100 students, for 100 students. So that's why the total down here is 100, right? It says complete the table by inserting the missing values. So how it works is that the total across here, for example, equal that. And the total across here equals that. That's one way. But then the total vertically this way equals that down there. So let's call it a two-way. These two equal a value down here and so on. You get me? That's how it is. So we can fill it out anyway. So for example, we can fill out this value because we know that this plus this equals this value right here. So the value right here is going to be 23 minus 15. So we can do 23 minus 15. So we're talking, man, 8. So this is 8. That is 8. And then now we can add up these across here, so, and put the value here. So we're going to get the 8 plus the 18 plus the 26. That's 52. So this is 52. We could have also done this, you know, the 100 minus 52. So we could have gotten it that way as well, right? For right here now, what we can do this value minus these two. And these two add up to 29. So we can do 48 minus 29. So we can do 48 minus 29. I get 19. And then 19 and 18 give you this value, which is what? 37. And you can double check if these give you back the 100. And they do. So the table is completed. Easy like that. That part finished. Next part says, a student is selected at random. A student is selected at random. What is the probability that he or she, so we're talking about all the students now, you know, all the students, he or she is being driven to school each day. So you need to know the total who drive. See, total who drive here, out of the 100. So that, this total is comprised of the boys and the girls. So the probability is 40 over 100, which is what? 4 over 10 or 2 over 5, right? Huh? That is the answer. 2 over 5. 4 over 10, that's all? Which is 2 over 5. That is it. Next part says, one girl is selected at random. So we are now focusing on the girls alone. And there are 52 girls. One girl is selected at random. Focusing on the girls only now. There are 52 of them. What is the probability that she did not cycle to school? So if she never cycled to school, it means that she do this one, walk or drive. So it's basically probability of getting one of those, not one, no. Probability of getting that she did not walk to school, did not cycle to school. So probability of getting that she walk or drive. So if I add them up, so this becomes 18 plus 26 over the total of 52 girls. That's going to give you the answer. Let's see what it is. The calculator tell me. 8 plus 26 over the 52. See it as a fraction. This is it. 17 over 26. This becomes 17 over 26. That's the probability of getting a girl who does not cycle. And if you don't cycle, it means that you walk or drive. That's the answer. All right. Another way to do it is to find the probability that you cycle and subtract that from 1. That's another way to do it. Because the total probability has to be 1. So you could have done it another way by finding the probability of she's cycling, which is 18 over 52, and then take the complement of that, which is to subtract it from 1. All right, that's another way to do it. All right, you get the same answer. That question done. Next one, number 6. Number 6 right here. Measurements. It says, Farmer Brown makes troughs to feed his farm animals using wood that is 5 centimeters thick. So see the thickness up here, the shaded thickness is 5 centimeters, all right? 5 centimeters thick. It says, as shown in the diagram below, the trough are rectangular base, open at the top, and have external dimensions 200 by 190 by 160 centimeters. So they're showing the external dimensions. Remember, the material is 5 centimeters thick. The top is open. The bottom, therefore, also has 5 centimeters thickness under there. Question says, show by calculation that the internal capacity is this. So to get the internal capacity, we need the internal dimensions. It's like internal volume. Let's draw them in on this diagram. Internal dimension. Let's put them in. Let's go across here. So first, internally. Internally across here. Externally, it is 200. We have to subtract 5 on this and 5 on this. So subtracting 10. So diagonally, this is 290. Internally, centimeters. Then now we need this dimension, this length down here, so that dimension. So again, overall means a different color. Use up what we have. This way now. Front to back. I'll put it over here, so. I know why I'm putting it over there. So externally it is 190, but you have to subtract 5 from this and 5 from this. So internally it is 180. So this is 180 centimeters. Then the depth of the box. Internally, let's do that part in purple. Only the bottom alone have 5. So like you have a 5 centimeter thickness internally there, so. That is shown over here. This is the internal depth of the box. So I can draw it on this one in purple. So we're subtracting 5 alone now, because they're on the bottom alone covered. So it would have been 160. Subtract 5, it becomes 155. So this is 155 centimeters. Down here, 155 centimeters. So the internal dimensions are 290, 180, and 155. Let me write the 180 better. This not look so good. Let's write this better. 180. 180 centimeters. Good. So the internal volume, therefore, let's call it volume internal. Let's call it that. Internal volume is equal to 290 times 180 times the internal depth of 155. That must give you this figure. Don't give that figure, there's something wrong. Don't it? Voila. 8091000 centimeters cubed. Lovely. That was shown. This is measurements, easy question. Almost like common sense. All right. Next part says, calculate the volume of wood to make the trough. So the volume of wood is the total volume of everything minus the internal volume that has nothing. So the outer volume minus the internal volume gives you the volume of wood. So if we calculate the volume with these external dimensions and subtract this volume, let's write it like this. So the volume of wood is equal to the volume external minus the volume internal. The volume external is external dimensions. They're going to multiply. I can write it out up here. The volume external is going to be the 300. What are they again? 300 times 190 and 160. 300 times 190 times 160. All right, let's shift it down and put it here. So, what is work out to? Never work it out. Never work it out. Just put it right here, so by itself. But anyway, let's work it out still. All right, so it's 300 times 1. I don't like to calculate unnecessary things, honestly. I don't like to calculate unnecessary things. I didn't need to work out this value. I could just put this figure right here, so. Right? And let's do the one calculation. But anyway, 9120,123 minus the original figure was what? This thing right here. Let's copy it down. Can't bother write it over. Let's copy it down. And put it here, subtracting that. All right, and get the final answer in CM cube. So we're going to subtract now. See what I'm putting on the calculator, what we could have done instead of calculating the volume here so first. We have done that and subtracted 8091123. And it would have been 1029123 centimeters cube. Is the volume of wood in that box. That's question like this all the time. Next part says now, Farmer Brown must pay the internal surface of the trough. So that's the four sides and the base. Internal surface, right? And what's the internal wall? It's the internal surface. You have to include the base internal, right? It says, give it that 1 gallon of paint. 1 gallon of paint this amount. 280,000 centimeters cube of surface. Determine the total amount of paint, and I want it in liters, needed to paint the internal surface of the trough. So we need to find the total internal surface area of the trough. We divide it by this amount, we will know how many gallons of paint we need. And then now we can convert that number of gallons of paint to liters by multiplying by that. So we need to know the total internal surface area that is going to paint now. You understand that? So total internal, just the area, not the surface area, just the area, equals, what were the dimensions again? Don't do it piece by piece. So you had two of the walls at the back here, so internally, two of those walls, which were 150 by 290, two of those walls. So that's a 2 times 150 times 290. 2 times 150 times 290. Plus 2 side walls, 2 long sides, which is going to be, in that 115 is 155. 155. 155 times 290. That's here at the back wall. Front and back. They have 2 side walls. 2 side walls, this side and that side. Let's call them side, which is now 155 times 180. 2 of them. 155 times 180. So it's 2 times 155 times 180. Then we have the base, which is just 1 base. And the base area is the 290 times the 180. The base area is 290 times the 180. 290 times 180. That's the base. So we're working this out and adding them up. All right. So it's 2 times 155 times 290 plus 2 times 155 times 180 plus the 1 base, which was 290 times 180. So I'm getting 179,900 centimeters squared. So remember now, if you use this amount of paint per liter, per gallon, which is only this, 1 gallon to this area. So I'm not going to need a full gallon of paint, you know. Now we need a full gallon of paint. It's a fraction, because that's a fraction of this area right there. So. Right? And now we need a full gallon of paint. All right, so let's work it out this way. Volume of paint needed is going to be the total volume of paint, 179,900 divided by the amount for 1 gallon. Or should I say gallon of paint needed, not just volume, gallons of paint needed. Because this amount is for 1 gallon. So if you want to know how many gallons this is going to take, you divide it by the amount for 1 gallon, which is 280 1,000. That gives you the amount of the gallon that is going to need for that. So let's work it out. It is 179,900 divided by 280,123. So getting 0.99, let's put as a fraction, yeah? 0.99 something, eh? Put in what? Or is 2 and 8? All right, thanks. 2. All right, so we get the exact value there. So now we get 0.6425 gallons. But I want it in liters. And this amount of liter equivalent to 1 gallon. So we're going to multiply this now by this amount to get the liters. So that is equal to 0.6425 times the rate, or the conversion rate to liter, which is 3.79. And that's going to be the amount in liters that we need. So we're going to multiply this now by the 3.79. So we're going to need 2. I write out everything, you know. 435. Or them said in the decimal place nothing. I'm saying anything about that or accurate? No, they never said that. So I write out everything. So it's 2.435075 liters is gonna need. That is it. Hope you understand. So okay, I get the total area internally. I'll divide it by the amount that to do 1 gallon. That tells you how much gallon you need. And then to convert from a gallon to the liters, now we have to multiply by this 3.79. All right, that is it. That is it. That's not the only way to do it, but this way good enough. All right, let me shift this over here. Put an equal sign there and put a bracket around this total here that worked out. That's a total surface area internally. Total internal surface area is this. All right, let's continue. That question done. Pattern question. Don't need a calculator right now. All right. This question says, the first 3 figures in a sequence of shapes formed by connecting lines of unit length are shown below. So clearly you can see that you have this house looking thing and I keep adding on one to each other, right? So to get the fourth shape, we need to add on one more like a house thing onto this. And I want us to draw the fourth figure right here. So I'm going to add on one more like a house looking thing onto this one. So it's going to be bam, bam, bam. And then come up to about here. Don't go all the way up and do about there. If I add that onto there, that will be my fourth figure. And I've seen question set in CSEC now, where they actually draw the third figure for you and ask you to complete it to get the fourth figure. I've seen that. So they're making it easier for you these days. Right? So like they give you this as a start of the fourth figure and ask you to complete it. But let's finish this up though. So to get the fourth figure, I have to draw about the third one. And let's move it over. That's what I'm going to do. I have to use up the technology that I have on the screen. Hold on a second. Hello? 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 I'm in class, you know. I can't watch him. I'm in class. I'm in class. I can't watch him. All right, I'm in class now. All right, later. All right, guys. So that is that. That's figure number 4. Nice and easy. Sorry about that. Next question says, the number of lines L in each shape and the perimeter P of the shape follow a pattern. Study the pattern of numbers in each row of the table below and answer the questions that follow. Complete the table below showing the number of lines and the perimeter for each figure. So basically I want us to fill out for these. This one, and that one. So as usual, I prefer to do the formula line first because it will help me with these other lines. All right? Especially when it's a simple type, we keep adding the same number of values each time. So here I keep adding 5. I keep adding 5. So because I keep adding 5, we know that 5n is a part of the formula. But the first figure has 6. 5 times 1 is 5. You have to add 1 to this to get the formula for that column. Over here, I keep adding 3. Plus 3, plus 3. So because I keep adding 3, the formula starts with 3n. But the first figure has 5. 3 times 1 is 3. You have to add 2 to that to make 5. So that becomes the formula for that column. And once you have the formula, you're good to go. To find the figure for here, I just need to drop the 5 on this formula. 5 times 5 is 25 plus 1 is 26. So this right here is 26. Drop this 5 on this formula. I get 3, 5, 15. 2 gone somewhere. 3, 5, 15. 15 and 2 is 17. So right here is 17. Then this now, to get this value, what I know is that the formula now is equal to 66 to give me this value. So when I put it right here, the formula, which is 5n plus 1, is equal to 66 in that row. Subtract the row first, subtract the 1 first, get 5n equals 65. Then divide by the 5, we get n equals 13. So right here is 13. Well, we know that that is 30. We can take the 13 and drop it on the end down here, so now, to get the other value. 3 times 13 is 39. 39 plus 2 is 41. So right here is 41. Table done. Quick and fast. No need to think. We do it that way. All right? That's it. You want to reduce the amount of thinking you need to do in the exams. You don't need to think in the exam when you're well prepared. Just do. Next question. It says, write a simplified expression in terms of n for the difference d between the number of lines and the perimeter in figure n. So basically I want the difference between these two numbers. That's what I want. They like them more L minus P. Let's make sure. Write an expression for the difference between the number of lines L and the perimeter P. So you like the one, which one larger? Which one always larger? This one larger, right? See, this is always larger than this. So they want L minus P. So they want this figure minus this figure. So they want L minus P. This question is asking us for L minus P. So the L is what? 5n plus 1 minus, that is 3n plus 2. You have to be careful with the negative sign. So it's 5n minus 3n. 5n minus 3n is 2n. Then it's 1 minus 2. 1 minus 2 is negative 1. That's it. Argument done. Question done. Let's stop the noise of the cheese sticks bag now. That's it. Let's have cheese sticks bag I make nice. Next question. Next question. It says, Marla buys 2 types of mobile phones, B Flow and C Flex, from a company to retail. So she wants to sell them back. It says one B Flow phone costs $60, while one C Flex phone costs $80. We can't bother the B Flow and the C Flex. We're going to say B and C. Let's make a note. So the B phone is for $60 each, and the C phone is for $80 each. I'm extracting information from this wording. I don't have to write it back. I don't have to search back for it. It says she buys XB phones. She buy extra phone here. She buy extra phone here, and she buy YC phones. Y of these phones. All right. So X is the number of B phones, Y is the number of C phones. $60 for a B phone, $80 for a C phone. This is the number of phones I should buy. These are just the types of phones, all right? It says Marla must not spend more than 1,200. She can't spend more than it. She can spend 1,200 or less. She's not spending more. Right hand inequality represent this information. So this is the money she spend on the B phones. 60 times X is X phones, $60 each. That's 60X. Plus, this is what she spent on the Y phones. $80 each, and it's Y of them. That's 80Y. And she can't spend more than $1,200. So this total that she's spending has to be less than or equal to 1,200. And then simplify this down. This can be divided down by what? 20? Don't it? This can be divided down by 20. So you're going to simplify it down. Divide through by 20. Carry down to the lowest terms. When I divide this by 20, I get 3. That's 3x. Divide this by 20, I get 4y. Divide this by 20. 120 divided by 20, I get what? 60? 60 over here. So that's right? Don't it? So this is my equation. That's my inequality. First inequality. Stop being nice with the thing, please. Next question says, the number of B phones must be, remember the number of B phones is X, you know. Let's make sure. Yeah, X. Number of B phones must be greater than or equal to the number of C phone, which is Y. It says, write an inequality to show this information. See there, X must be greater than or equal to Y. But remember in this class, we don't like when Y is on the right side of the inequality. We like when the inequality is such that the Y is on the left side. Because when the Y is on the left side and the Y is positive, less than means below, greater than means above. So I'm going to take this and spin it around. Because it's the same as saying Y is less than or equal to X. Same thing. So I prefer to work with this. Means the same thing. If X is greater than or equal to Y, then Y is less than or equal to X. You can read it from this side, from the right side. Y is less than or equal to X. So this means now that we want below the line, Y equals X. That's what it means. More than likely, we have to draw this on a graph. Let's continue. See there? We have to draw up on a graph. Now this question says, represent the two inequalities on the grid below. Label R the region that satisfies both inequalities. Now this question had a problem. Because they give us a scale where they had 4 units, 4 centimeters, 4 units, 4 centimeters, and I put 5. Same thing on the y-axis, 4 centimeters, and I put 5. Then up here, they have 5 centimeters, and the jump was 5. Right? So because of that, what I would do in the exam room for this, I would make an adjustment. All right? I would adjust the scale and put in the right thing. All right? I'll put in the right thing. But let's put on some points that we have to draw first. Let's put on some points that we have to draw first. Based on inequality. I'm going to put them on in red. So for this one easy. This one means below what we're going to represent. I don't have to write this out in, but this one means below. Why is it below? Because whatever is positive, less than means below. The line is solid. It's a solid line we'll have to draw. Why is it solid? Because the equals a part of inequality. And the line is y equals x. Nobody knows y equals x is an easy line. You pass through the points where the x and the y value is the same. So if you pass through, for example, 0, 0, and to also pass through 20, 20. Since you have 20 on the graph. Then this one up here now. This one means below again. Why? Because the y over here is positive, so the less than now means below. Less than means below. And then now, the line is solid because the equal is a part of the equality. It's going to be drawn a solid line. And the line that we're drawing is the one associated with this inequality, which is 3x plus 4y equals 60. So let me put it right here just to show you how we get 2 points on it quickly, right? We're doing the line, we'll put it over here. So 3x plus 4y equals 60. And we need 2 points on it. We need to put 2 points so we can draw the line. So 2 easy points to draw normally. One way give the x value 0 and the other one give the y value 0. Then you can use the equation to work out the corresponding value. So the point where x equals 0, this is going to be 0. You're going to be left with 4y equals 60. If 4y equals 60 divided by the 4, you're going to get y equals 15. So when x equals 0, the y is 15. So 1 point on the line is 0, 15. Then for this point where the y value is 0, like I put the y value equals 0 right here, so that's gone. You're going to be left with 3x equals 60. If 3x equals 60, then x is 20. So another point on it is 20, 0. So these are 2 points on that second line. 0, 15 and 20, 0. All right? So first thing I'm going to do, I'm not going to use this scale and complicate it. I worry about them scale. I'm in a business. In the exam room, I do this. I tell you what I'm doing. I'm going to make it easy for myself. Not going to get any values. Okay, I'll find my white. Let's use this. So I'm marking out these. I'm marking these out. I'm not using this. I'm marking these out. I'm not using those. But that's not right. Problem marking them out is that one of the values might not work. Because on the x-axis, and when I stop the class, I'm going to don't eat, cannot disturb me now. Down here, we need to go to 20, 0, right? 20, 0. We can't fit 20, 0 on this because this should be 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? So it can't work. So, since it can't go 1, 1, 1, I don't care, I go 2, 2, 2. I'm going to change the scale. I'm going to go 2, 2, 2. So I'm going to go 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm going to do that. There's a different scale on the y-axis. The 20 can work on the y-axis. So we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30. Oh, 20 can't work either. Hey. I don't know what kind of graph them give this in the exam. 20 can't work either. So it looks like 2, 4, 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right? So I'm going to use that. That's what I'm going to use because the scale that they give us kind of messed up. All right? I'm going to put on the points now. So first one is y equal x. This one. Let's put on this one first, the easy one. So pass through 0, 0. Right here. Come on in red. Pass through 0, 0. And pass through 20, 20 up here. So I go right in the middle of the graph. Right? That 4, 4, 8, 8, 12, 12, 16, 16. So you need that straight line for y equals x. Label the line with the y equals sign. Y equals x. I want below that line. Below, right? Below that line. So put the arrow pointing down. Which means that the region that we want is under here. We need to put in the other line now. The other line pass through 0, 15 and 20, 0. 0, 15 and 20, 0. All right. So this is 20, 0 right here. And it pass through 0, 15. Now where would 15 be? Now right here, so is 12. This is 14. This is 16. So 15 is going to be right here. Right there, so it's 15. Right there, so it's 15. So use the ruler and draw the line. All right. Use the ruler and draw the line. I'm trying to see if we can get another point, but use your ruler and you draw that line. You need to see where they intersect. So that is a line, and this would be bang 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 bang. What is it again? 3x plus 4y equals 60. It should be 3x plus 4y equals 60. I want below this line. And the question says, which region you want? The region that you want, they must mark it with an R, right? That's what they said. Label R, the region which satisfies both inequalities. That's under here. Below this line and below this line. So it's the region inside here. So we put it in purple. Below here and below here. Down here is the R. That's the R. Next question now says, the total number of mobile phones represented by x plus y. According to the graph on page 23, what is the largest possible value of x plus y? So to get the largest possible value of x plus y, you have to go to the vertices. So you go to the vertices. These are the vertices here, here, and there. Now this one, the possible value of x plus y, this is 20, you know, because that's 20 plus 0. X plus y equals 20 right here, so right? What is x plus y here, so? That past 20. Now this is about 8. Remember, so that's 9. It's about 8 point something. And I reach 20 now. It's about 8 point something. It's on this line, so the x and y value is the same. Because on the line y equals x. So it looks like about 8 point something. It now go past 20. 8 point something and 8 point something. Now I reach 20. But understand that? Good. So this will be the other vertex, but it's less than 20. Because about 8 point something. 8 point something, 8 point something. Right? So 8 point something, 8 point something. It not even reach 10 and 10. So you can't reach 20. So this way you're gonna have the maximum. Right out there, 20, 0. This now reach 20. The sum of x plus y right here, so is less than 20. If I even know the values, don't matter. Less than 20. So this is where we're gonna get the most. X plus y equals 20 at the point 20, 0. So see here, what is the largest possible? X plus y equals 20 is the maximum. Largest possible value of x plus y, 20. At the point, you can say it, at the point 20, 0. The largest possible value of x plus y, 20. That done. Next part, quadratics. It says, the table below shows pairs of values of the function. That's a smile-shaped quadratic function. All right? And they give you all the values. So because they give you all the values, you're blessed. You can see that the values are symmetrical about this line. The y values I'm talking about, you know. That's how you know the symmetry. Because these x values are all going up by 1. The y values are symmetrical about this line. Okay, see? You go this way, that way you get the same values. 4, then negative 2. See there? Negative 4, then negative 2. Then 2, then 2, then 8, then 8. So the values are symmetrical about the line right here. That line is halfway between negative 1 and 0. Halfway between negative 1 and 0 is negative a half. So you know what your axis of symmetry would be x equals negative a half or negative 0.5. So to get the y value down here now, you just need to plug the negative 0.5 into that to know where your axis of symmetry is at your vertex point. This is the axis of symmetry already, you know. X equals minus a half. That's a line that divides your values such that they are symmetrical. The values are symmetrical about that line. To get the vertex point now, you need to know the y value where x equals minus a half. You can just plug the minus a half in this. You can work it out if you want. It says, what it says, write down the maximum or minimum value. So I can actually work it out using the YT and calculate it. Or I can deduce it from this. X equals minus a half. So it will be minus a half squared. And then minus a half. Because this plus x is same as minus a half. So I'm going to minus a half again. And then minus 4. Now this is minus 4.5. And then you're adding back a quarter. So it becomes minus 4.25. Let's write it out. Minus 4.5. That's what this is. And they're adding back this quarter. Because a half squared is a quarter. This is same as minus 9 over 2 plus a quarter. This is 18 over 4 plus a quarter. That is minus 17 over 4. So that becomes your minimum value. It's a minimum. But if you want to do it this other way and calculate YT, it's actually going to be a minimum. So I'm going to cross this out. It's going to be a minimum. It's your YT value, which is 4AC minus B squared over 4A if you want to use that method to work it out. It's going to work out to the same way. Let's look at it. 4 times A, what's the A value? The A value is 1. The coefficient of x squared is 1. Times C, the C value is negative 4. Minus B squared, the B is 1. Coefficient of x is 1. So you're subtracting 1 squared over 4A. That's 4 times 1. See, you get this become negative 16 minus 1 over 4. So you get the same thing, negative 17 over 4. So I gave you 2 ways to do it right there by recognizing where the vertex is. All right, this up here is what I worked out. This is what I worked out down here. Become negative 17 over 4. Negative 17 over 4. But if you want to calculate it using the YT formula, that's fine. You must know that your minimum value is the YT value. All right, so this is the answer right here, negative that. It says, use a ruler. Using a ruler, draw the axis of symmetry. The axis of symmetry is this. And right down the middle here, so x equals minus a half. So it's x equals minus a half. We have to draw. They want us to draw the graph too. We didn't plot the points. We have to draw the graph. The first part was to complete the graph on the next page. Over here. So axis of symmetry is y equals x equals minus a half. That's this line. That's the axis of symmetry. So you use a ruler and draw it, right? X equals minus a half. And you're putting in the values. Because I know the symmetry of the value, I can actually put them in from here now. So this point coming across to here, I'm going to get a point over here. You can check it if you want. I'm going to get a point here based on this. This one is 3. It's going to go 3 on the other side of this. 1, 2, 3. Get a point there as well. Then this point is 1, 2, 3, 4, 5 to the axis. 1, 2, 3, 4, 5 over here. And the values are symmetrical about the axis. Right? Instead of going back and look. So this one is 1, 2, 3, 4, 5, 6, 7. From the axis, it's going to go 1, 2, 3, 4, 5, 6, 7 right there. Those are the points. If you go back from the table and plot the points, those are the points. Then remember the vertex point is on this line. And it's at negative 17 over 4, which is same as negative 16, negative 4. Negative 4 and a quarter. 4 for 60. Negative 4 and a quarter. That's where the vertex point is. Negative a half, negative 4 and a quarter on the axis of symmetry. All right. So I'm going to put this point on the graph as well. Negative 4 and a quarter down here. So you can't draw the graph and just come straight across here. So you have to recognize that it comes down to a turning point, negative 4 and a quarter. All right, let's see where a quarter would be. So this will be 3.2, 0.4, 0.6, 0.8, and then 4, right? So each line is 0.2. And we're looking for 0.25. We're looking for negative 4.25. So if I remove this so we can see it, this is negative 4.2, negative 4.4, negative 4.25 would be about here, corresponding to around this point right here. You have to draw your graph down to there. Everything important. All right, let's put back this one. So your graph is supposed to pass through those points, must come down to this minimum point here. So let's draw it now. So it's gonna go like this. That's it. Let me show you identify this minimum point. It's minus a half, minus 4 1/4, same as 4.25. That's a minimum point. Your graph must come down to that minimum point. Otherwise, you're not going to get the full marks. All right? You're not going to get the full marks if you don't do that. All right. Next question. I say, look up there, so. All right. You can watch the video and see it more clearly. That question done? Yes. All right. So I had to make an amendment to this question because these values were inconsistent. But there's no way this can be 68 and that be 106. You understand? But that happens in CSEC all the time. They give wrong values sometimes. So if I'm going to leave the 106, I'd have to change this to 74. Because the total angle on this straight line, this angle, look why. This angle right here, because of this angle right here, has to be equal to this angle over here. Why? Because remember, angle between a tangent and a chord is equal to the angle subtended by the chord. So this angle equals that angle. And then total angle on this straight line must be 180. But 106 and 68, 106 and 68 don't add to 180. See that? So in the paper that I gave you, I made the adjustment and I put this angle as 74 so that it can work. Right? So there's consistency in the values. So this angle we're working it as 74 degrees. That's what I gave you on the paper. I don't think I changed it on the one that I sent over, but that is what we have to work with, 74, for it to make sense. All right? For the values to be consistent. All right. This question then says, so changing this to 74 as well, this right here. This 68, I'm going to change it to 74. If I'm in the exam, I change it to, you know. I tell you, in the exam, I'm changing it. I'm not busy with them. I put the right thing. I make them know so me know my thing. I change it. Can't be 68. Cannot be 68. So I'm changing either the 60, either I leave the 68 and change 106. I mean, I leave the 106 and change the 68. In the exam room, I'm doing that. All right, so I'm going to put 74. Yes? If what? Which one? Yes, sir? Huh? Yeah, but it would have to be 74, don't it? Yeah. And then if that's 74, then this over here have a 74. That's what I'm saying to you. And that's why I changed it in the test to 74. It can't be, this can't be 68 and this be 106. There's going to be inconsistency in the values. But anyway, let's work with this. Let's work with this. Then now, based on that information, you have everything here. This and these two lines parallel. So that's a transversal line. So these angles now are U angles, right? U angles. So let me say this over here is a 74 as well. This is 74 too. All right, but let's answer the question. Let's not get idea for ourselves. All right. So it tells us of those parallel lines. See here, it told us of those parallel lines. This one and this one. So we have the Z angles. We also have Z angles here. So the angle here and the angle here is a Z. All right. All right, let's answer the questions. It says, determine the value of each of the following angles. Show detailed working where necessary and give reasons, give a reason to support the answer. First angle I want is angle ECD. Angle ECD. ECD. That's this angle up here, so I want. ECD. All right, we're going to find that angle now. Well, since this line is a parallel line to this one, then basically this is a Z angle. See that? So the angle and the angle are the same. See that? It equals 74 degrees. Z angles. Because them two lines are parallel. Look. This line and this line parallel. This becomes like a transversal line. The one, this angle. It must equal the angle over here. So Z angles are equal. alternate angles. So it equals 74 degrees. Let's put it on. So this angle right here is also 74 degrees. All right. So I'm going to write 74 degrees. 74 degrees. I'm going to write alternate, which are also called Z angles. Are equal. That's the reason. All right. That one done. Next one. That's the reason. Next angle I want is CEG. Where is that? CEG. 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 CEG up here. So that one easy again. That's this angle I want right here. So that CEG is this angle. That one easy because remember now the angle between this tangent and this radius is 90. So this angle inside here so must be 90 minus 74. 90 minus 74. This angle that I want right here has to be 90 minus 74. Much is that? 90 minus 74 is how much? 16 degrees. Angle between a tangent and a radius is 90 degrees. So this angle equals 90 minus 74, which is 16 degrees. What's the reason? Angle between tangent and radius is 90 degrees. So the total angle is 90 degrees, and piece of it is 74, so that piece must be 16. Now, next part, CGF. CGF. Where's CGF now? C to G to F. So they're talking about this angle up here, I want now, that angle. All right. So how we can find that angle now? Well, that angle, let me put it in red, put it in red. This angle up here is supplementary with this angle because this thing is a cyclic quadrilateral. That's a cyclic quadrilateral, right? So if we can find this angle down here, so we can do 180 minus it and get that one. So question is, what is this angle down here so equal to? All right, we can find that angle now. Now, I can use this Z. And say the total angle over here is 106. Right? And this piece is 74. So it means that the angle inside here has to be 106 minus 74. But understand that? But understand that? So this angle in here, let's mark it in purple, has to be 106 minus 74. Because all of this is 106 because of that red Z. These two angles equal. Right? And if this piece down here so is 74, then the remaining piece in here must be 106 minus 74. So this angle is 106 degrees minus 74 degrees. How much is that? 32? That's 32 degrees. And then after that is 32 degrees, then this angle up here then is 180 minus the 32. Supplementary angles, right? 180 degrees minus 32 degrees. What that work out to? 148. I'm sure that's not the only way to do it, but good enough. So I'm going to tell the examiner first. Well, actually, the working out is here now. So I'm going to tell him that this angle CEF is this first. CEF is that. CEF. First, I'm going to say angle CEF is 106 minus 74. That's what we said, right? Which is 32 degrees. And that's because of Z angles, right? That's because of Z angles are equal. Z angles are equal. And then now, the angle that we want up here becomes 180 minus 32. And then the angle that we want, angle CGF, becomes 180 degrees minus 32 degrees, which is 148 degrees. That's right, the reason now, because opposite angles in a cyclic quadrilateral are supplementary. Which means that they add to 180 degrees. All right, that's that cyclic quadrilateral there. Yes? Yeah, man, same thing. Yeah, you don't have to use the word supplementary. All right. All right. Next question. Next question says, from a harbor H, which is right here, the bearing of two ships, Q and R are 0.69, what they show you, and 151 respectively. So it means that the angle over here is 151. Because it's a bearing from H down to R. So that angle that I'm marking out is 151 degrees. Clockwise from the north line is 151. Let's write it better. Let's write it better. So it means that this angle here that they didn't show us, clockwise from the north line all the way over to here, is 151 degrees. That's a bearing of here from H. All right, that angle is 151 degrees. It says Q is 78 kilometers from H, while R is 242 kilometers from H. So 175 and 240. Let's put them on in red. So this distance is 175. Put on in red. 175 kilometers, that distance. And down here, so we'll show this one, 242. All right, that is that. Question says, complete the diagram above to show the information given. So we put on the angle, we put on the distance that they didn't show. All right, then say calculate QR, the distance between the two ships. That's this distance I want. So to get that distance, we need the angle between here, which is easily 151 minus the 69. So this angle inside here becomes 151 degrees minus 1 minus 69. What I work out to? 69 degrees. How much? 82? 82 degrees. So this angle is 82 degrees. 82 degrees. Because we have that now, we can use cosine rule to find this side. All right, so let's do that to find QR. Let's do it down here. So QR squared would be, start like Pythagoras theorem, to be 175 squared plus 242 squared, start like Pythagoras theorem. They subtract a piece, subtract 2 times the 175 times the 242 times the cosine of the 82 degrees between them. Instead of putting a square on here, we can take out the square and just square root this one time. And so we have one calculation for QR. So we don't need to write 2 lines. All right, we don't need to write 2 lines. Let's drop it in the calculator now. So it becomes the square root of 175 squared and 242 squared minus 2 times 175 times 242 times the cosine. Make sure the calculator is in degrees. Yes, it is in degrees. I can see the DEG up there. Cosine of 82. and I get in 278. And did they say anything to the nearest kilometer? So the nearest kilometer is 278 kilometers. So the nearest kilometer means that you don't put a decimal. You run out to the nearest whole number. I know that one we're going to put on the diagram. This is 278. 278 kilometers. So it means that going forward now, we can use a sine rule. Because the only thing we don't know now is this angle and this angle. So any one of them we need to find, we can use the sine rule because we have this angle and side opposite each other. We know both of them. So we can use the sine rule going forward. All right? And more than likely, we have to use one of them to find a bearing, which is always the case with these questions. So they keep asking the same thing all the time with different values. That's why you must get these questions right. But they're asking the same thing all the time. It says, how far due south? Well, this one a little bit different. How far due south is ship R of Arbor H? In other words, from Arbor H to R, how far south is the distance? What distance is this asking us? Let's put on the diagram the distance asking us for. From H to R, how far south? So R down here, so they're actually asking us for this distance down here, so down to the east-west line, down to H. Asking us for this distance. How far south R is. This is the cardinal line, east-west cardinal line for where R is. This is the distance how far south it is. That's what this one they're asking me for. Let's call that distance X. So I'm going to draw about this now, form that right angle triangle. So that's an east-west line, that's a north-south line. Question is asking for this distance. If they wanted how far east, it will be this distance. They wanted how far east R is from H. That will be this distance, but they want how far south. So question is asking us for this distance, which we're going to call X on the diagram. All right, so we're going to be working in this triangle now. So since we're working in that triangle, it is a right angle triangle. As I said, that's an east-west line, that's a north-south line. So this angle inside here is 90. That's a right angle triangle we have. And so if we can find this angle now, we're good. Let's put on that angle. Let's put on that angle in purple right here. It's quite easy because the whole of this is 151. And total angle on a straight line is 180. Then the angle inside here is 180 minus 151. Let's work it out here. 180 degrees minus 151 degrees, which is equal to how much? 29? 29 degrees. So this angle in here is 29 degrees. So I'm sure you know I get the 29 out here. And I'm going to just write it in here. 29 degrees. 29 degrees. And the question is asking for X. So in that right angle triangle now, this is my hypotenuse, 242. I want the adjacent, I'm going to use cos to find that distance, cos. Let's show the calculation here and then copy it down. Let's show it up here. Let's show it over here. So I'm going to write that the cos of 29 degrees equal the adjacent that I want, which is X, over the hypotenuse 242. Take 242, I multiply it up here, I get X. I'm going to copy this down then and work from this. Move it down, cut and paste it where I want it down here. Paste it here. So I'm going to tell them that the distance that I want equals X. So I'm saying to the examiner, this distance they ask me for equal X. Because I'm leaving that on my diagram now. I'm leaving this on my diagram. Part of my solution. And I'm telling him that the distance that I'm calculating here that they ask me for is X on my diagram. So I calculate X, I calculate the answer, that distance that I want. So from this now, let's multiply this up here. So it's going to be that 242 times the cos of 29 degrees is what's going to be equal to the X. Therefore, the X equal, I'm going to work it out now and write it. So it becomes 242 times the cos of 29 degrees. And it is to the nearest kilometer. I'm going to write 212. 212 kilometers. I'm giving them 212, three significant figures. All right, next part. Hold on a second. Hold on a second. All right. What you running down? Oh, that question done. Nice. One question to go. What time is it? I mean at 7 o'clock, you know. I mean at 7 o'clock. So important, very important meeting at 7 o'clock, you know. And I'm here with you guys. Tongues. Let's go. Next question. I don't think we need a calculator now. Come on, let's finish this up. All right. This one wants us to calculate this product. First thing you need to do is find out the order of the result. This is a 2 by 2. We're going to use the rows of this matrix and the columns of this matrix. It has 3 columns. This is a 2 by 2 times a 2 by 3. Gonna get a, remember these two equal, so it's possible. The result is gonna be this by this. 2 by 3. So the answer is gonna be a 2 by 3. So let's set it up. So the answer for this is gonna have 2 rows and 3 columns. So we're gonna put in the values here, 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 here. Those are the values that we're trying to calculate. All right, let's go step by step now. Let's go step by step. So remember, you take the rows from the first matrix and you take the columns from the second matrix. Ready? This first value is in the first row and the first column. So to get it, we're going to multiply this first row by this first column. Or multiply them again. Same way. First element times first element. Second element times second element. First element times first element. Second element times second element. 5 times 2 and 4 times 0. 5 times 2 is 10. 4 times 0 is 0. That's the first value. Then this value here, it's in the first row, second column. So to get it, we're going to use this first row with this second column. Same thing again. First element times first element. Second element times second element. First element times first element. Second element times second element. 5 times 1 and 4 times 3. 5 times 1 and 4 times 3. 5 times 1 is 5 and 4 times 3 is 12. Then this value out here now is positioned in the first row, third column. So to get it, we have to multiply this first row with this third column. Same thing again. First element times first element. Second element times second element. First element times first element. Second element times second element. 5 times negative 4. 4 times 6. 5 times negative 4 is negative 20. 4 times 6 is 24. Let's draw about the bracket now. Out here. Then I come to this line now. Let me write them back. Here, here, and there. Ready again. So this value now in the second row is positioned in the second row, first column. So to get it, we're using this second row with this first column. First element times first element. Second element times second element. First element times first element. Second element times second element. Negative 3 times 2 and negative 2 times 0. Negative 3 times 2 is negative 6. Negative 2 times 0 is 0. Then this value here, it is in the second row, second column. Second row, second column. Second row, second column. First element times first element. Second element times second element. First element in the row by the first element in the column. Second element in the row by the second element in the column. First element times first element. Second element times second element. Negative 3 times 1. Negative 2 times 3. Negative 3 times 1 is negative 3. Negative 2 times 3 is negative 6. Then the last value out here is in the second row, third column. So to get it, we're going to multiply this second row with this third column. Same thing again. First element times first element, second element times second element. First element times first element, second element times second element. -3 times -4, -2 times 6. Now, -3 times -4 is a +12, and -2 times 6 is a -12. Don't give away these questions. They're too easy. Just focus, concentrate. This becomes 10. This becomes 17. This becomes 4. This becomes -6. This becomes -9. And this becomes 0. And that is the answer. All right? So that's a calculation for 2 marks, but so you go. If you just do it, the body getting the same 2 marks for it. Don't worry about the marks. All right? If you never get it, go and redo it. Next question says, state why the matrix, state why the 2 matrices in A1 are conformable. They are conformable because the number of columns in the first one is equal to the number of rows in the second one. This is why they're conformable. Because the number of columns in the first one is equal to the number of rows in the second one. What are them equal to? Right? That's what you have to write it. Number of columns in the first matrix equal the number of rows in the second matrix. Let's write that. State why it is conformable. Number of columns in the first matrix is equal. And if you want to say 2, if you can say it says 2. That is 2. It's 2 columns. Number of columns in the first matrix, which is 2, is equal to the number of rows in the second matrix. You can say i.e. 2. You can say that is 2, and don't bother with this right as well. It don't really matter. The important thing is this. Number of columns in the first matrix equals the number of rows in the second matrix. And I'll learn nothing. Pay attention. All right, next question. What the inverse of that matrix? Just calculate it. Equals. I can say inverse equals. The inverse equals 1 over the determinant. 1 over the determinant. What's the determinant? The first diagonal product, which is -10, minus the second diagonal product, which is -12. So you're subtracting a -12. This minus becomes a plus. Let's put what the work out to. It work out to +12 minus 10. That's a 2. It work out to a +2. They multiply that by the adjoint matrix. Interchange the element on that leading diagonal, that main diagonal, that primary diagonal, that first diagonal. Interchange them. -2 goes here, 5 goes there. Leave these 2 elements on that second diagonal where they are, change the sign. So this 4 comes back same place as a -4. This -3 comes back same place as a +3. Leave them where they are and just change the sign. Then now it's just a matter of dividing each of these values by this +2. So you can put as a decimal since it's just divided by 2. So -2 divided by 2 is -1. -4 divided by 2 is -2. 3 divided by 2 is 1.5. 5 divided by 2 is 2.5. That's my answer right there. Yes? You could have used it as a half. So you can put -1, -2, 3 over 2, 5 over 2. Yeah, man, that's the same thing, man. Same thing that my dupes. Same thing that. Very good. But all right, finishing up, you know. The last question now. Time is it? Half an hour late for my meeting. Next question. It says the diagram below shows triangle OAB, where the vector OA is R. Look carefully. Now, this is R now, guys. The whole of this is R. So I personally don't like how them show this on this diagram right here. Pay attention. That R is the whole of this. All of that is R. I'm in the exam, I'm going to adjust it. I change it for myself. I don't want it mixed up. Next time I look on the diagram and think this is R right here, so when we're ready for work. In the exam, I change it. I don't want to get confused. I don't want to forget. Then OB is S. OJ says S. It says, in addition, E is the midpoint of CD right here. So E is right halfway between those 2 points. That's fine. Looks that way. But OC, you know, 3/4 of OA. This is 3/4 of the whole thing. All right. So I'm going to adjust it now. I take this off. I don't want that. R. The whole thing is R. I'm going to make my adjustment in the exam room. If the whole thing is R, and this is 3/4 of the whole thing, then it means that this vector down here is 3/4 of R. And the other quarter is from here to here. So I'm going to put it up there. This is the other quarter, 1/4 of R. But understand that? That's what I would do in the exam room if I were you. Because I don't want to look on the diagram and get mixed up and think that this right here says R. It looks that way on the diagram. You get me? That's what I would do in the exam room. All right, let's continue. Then it says AD is 2/3 of AB. This is 2/3 of the whole thing. So let's remind ourselves of it. This is 2/3, and so this other piece is 1/3 of AB. So don't forget, this is 2/3, this is 1/3. Because the whole thing is AB, right? So I have 2/3 AB and 1/3 AB. All right. Let's answer the questions now. Question says, write in terms of R and S, means R and S must be in the answer. The vector CD. First thing I want is the vector CD. That's the vector from here to here. Now watch this now. Looking at the diagram now. To go from C to D. I just need to come up to A and then go from A to D. But remember, the AD is 2/3 of AB, and I can't find AB because I know the portion vector of A and I know the portion vector of B. So I want to write it up here so right now. That the AB is OB minus OA. When you know the portion vector, you can use that. O on the last minus O on the first. So it is actually S minus R. That's what the vector AB is. S minus R. This. I'm going to need it. They never asked me for it, but I need it. Because I need to calculate 2/3 of it for this part. So let's work it out now. Let's work it out now. I want to go from C to D. I'm going to come up to A first and then go AD. See it here now? So the CD that I want is equal to C to A and then A to D. But this AD is actually 2/3 of AB. So I'm going to write it then as C to A and then 2/3 of AB. Now ready to put in the values now. Because the C to A is just a 1/4 R right there. And 2/3 of AB is just 2/3 of this. So it becomes 2/3 of the S and 2/3 of the minus R. So I'm going to write plus 2/3 of the S and then minus 2/3 of the R. That's what 2/3 of this is going to give me right here. But I go to that. Then you consolidate the like values now. So this is only S value in there. So I'm going to just write that first. That is 2/3 S. Then I'm putting these two together. Now this 1/4 is the same as 3/12. And this 2/3 is the same as 8/12. So 3 minus 8 is -5/12. times R. That's it. Understand that? That's what this and this would work out to. A quarter minus 2/3. Remember, hold on a second, guys. Just lost some internet a minute there. Setting up back. All right. Good to go again. Ready? So ready now. I was saying how we're going to find the vector OE. So to go from O to E, look at the diagram. We can go from O to C up here using this vector and then go C to E. Where the CE is just half of the CD that we have. So it can be worked out. We know CD, you know, and we just need to come half of it. So ready then, let's write it out. So go from O to E, we're gonna go O to C and then C to E. But the CE is half of this CD. So we're gonna write that. O to C and then half of CD. Half of CD. Another way that we can put in the values. The OC is what we're talking now. The OC is just this, 3/4 of R. So this is 3/4 of R. Add half of this. So we're going to half this and half that. So if you half this, you're going to get 1/3. And if you half this, you're going to get 5/24. So these are the like terms. I need to add the two of them now. So I want to put back this first as a 1/3 S first. And then to work out 1/4 and minus that. So this quarter is the same as 18/24. How am I get 18/24? Let's multiply by 6/6. Multiply this 3/4 by 6/6. Why do I? Because I want the two denominators to be the same. Right? So this becomes 18 over 24. Then I'm subtracting this 5 over 24 minus 5 over 24. It's not complicated. 18 minus 5 is 13. So this and this give me 13 over 24. So this is 13 over 24R. Easy like that. That's what this and this gives me. And this is working out for it. Not done yet. That question long. All right, let's go. Next part. I think this part is very easy. Question says, OQ and R, Miss Lewis, stop it talking. OQ and R have coordinates 0, 0, 5, 2, and negative 1, 4. Remember, if you know the coordinates, you know the portion vectors as well. All right. It says write OR as a column vector. So where is it? Since R is a point, negative 1, 4, then OR is going to have the same values, negative 1, 4, like that, as a column vector. All right? See here, R, negative 1, 4. So this becomes OR is negative 1, 4. Free mark, free mark. Next part, they want the modulus of QR. So the diagram is there now. So this question becomes very easy. You know. Let's look at it. QR is this line. The modulus of it is the length of it. So if I know how many units across and how many units down here, I basically have a right angle triangle and I'm trying to find the length of the hypotenuse. Let's look at the scale first. So every other line is 1 horizontally. So this is 1, 2, 3, 4, 5, 6. So this is 6 units long across here. And then vertically is again every 2 units is 1. So vertically this is 1, 2 units. 2 units. So I can find the length by using Pythagoras' theorem, square root of 6 squared plus 2 squared. Just like that. And get it quick like that, you know. So the modulus of this will become equal to the square root of 6 squared plus 2 squared. And I would leave those markings on my diagram. I'm not going to take them off. Whatever that work out will be the answer. This is 36 times 4. That's 40. Square root of 40 units. Modulus is length. But we could do it the vectors way. Let me write it here. Square root of 40 units. But we could also do it the vectors way. We actually calculate the vectors first. The vector first. So if we calculate the vector first, we're going to see that we're going to get 6, negative 2. Because to go from Q to R, let's look at it. Oh, the other way. To go from Q to R, you go 6 units to the left. That's negative 6. And 2 units up. Negative 6, 2. I can tell you that's what it is. The diagram is showing me that. You go from Q to R, you go 6 units to the left, and then 2 units up. So this is the vector QR now. I don't have to calculate it because the diagram is there. But let's calculate it still and show you. So if you're calculating QR using the vectors method, it will be OR minus OQ. O times the last minus O times the first. The OR we said was what? Negative 1, 4, right? Right here. Negative 1, 4. The OQ is 5, 2. Because the point is 5, 2. 5, 2. So negative 1, 4. Negative 1, 4. Minus 5, 2. See? Minus 1 and minus 5 is negative 6. 4 minus 2 is 2. See? Same thing I got on the diagram. Negative 6, 2. So when you have the diagram, it becomes easy because you're seeing it. And then if you want the modulus now, using these same 2 values, so you can write the modulus of QR will be equal to the square root of this value squared, but you don't need the negative because the negative squared is still positive. So you're going to write 6 squared plus 2 squared. Same as what we have here from the diagram, which is still the square root of 40 units. End of this test. And that is that. All right. So, you know the drill. Any question you get wrong, you go home and you redo it. Students online, same thing. Any question you got wrong, you redo it. You hear me, Miss Alexia? That's her name first on top. Alexia? Alexia sleeping.
Sir?
Oh, why are you sleeping?
I'm not sleeping.
Oh, so I don't answer.
I never heard you call me.
Yeah, no. Everybody here my caller except you. Anyway, I'm saying to everybody on the call, everybody in the classroom, you need to go and redo the questions that you got wrong. We have to improve from the next mock exam. We're moving the pass mark. Hey, I'm talking. We're moving the pass mark. And so you have to, why this girl keep talking when I talk, man? We're moving the pass mark. So, in order to move the pass mark, in order for you to move with the pass mark, you have to eliminate the mistakes that you made on this paper. You cannot go repeating the same mistakes again on the next paper. In order to eliminate those mistakes, you need to go and redo the questions that you got wrong. I don't mean to go and watch over the video. Watching over the video is not redoing the question. Looking at the solution is not redoing the question. Redoing the question means that you get a blank piece of paper and you redo the question. And you only look at the video to double check your own work. And if you get it wrong again, it means you have to do it again. You have to do the question out of your head. That's how you eliminate the mistakes. If you just watch the video alone, that's not good enough. If you just look at the solution alone, that's not good enough. You have to literally do the question over again. Do it the right way. Out of your head on a blank piece of paper. You're only using the video to assist you. To double check your solution and to listen back to the explanation if you get it wrong again. It don't make no sense. Come next week, you get a question that is similar to the ones that you're making mistakes on and you're making the same mistake again. It don't make no sense. It means that we're not making progress. We said that we're going to use a process that we call progress before perfection. You have to make the progress by eliminating the mistakes and the question that you don't know what to do, you don't know how to do them. We're not doing anything new. Everything we're doing here is stuff what we've been doing since September. There's nothing new. None of these questions are new. The majority of these questions were actually worked about already on those Saturday class that we were having. So none of this is strange still. We just need practice to cement the process, to cement the understanding. You need practice. Mathematics is not a watching video subject. It is not a reading solution subject. It is a doing subject. It's a doing the solutions subject. So you have to literally do the solutions, especially what you got wrong. You might look at the solution and say, sir, do it. I might understand what sir do. That's not good enough. To cement it in yourself, you have to actually do the question. You cannot be lazy and gain success in the subject. You have to put in the time and put in the work. Remember now, guys, you have another mock exam coming on Wednesday and a different one on Thursday. You have one Wednesday too. We don't have class every day now, you know. And not Monday and Thursday alone have class now, you know. We don't have class Saturday. We don't have class Sunday. We don't have class Monday. We don't have class Wednesday. We don't have class Thursday. 5 days a week we don't have class now. Just as some of the classes at home. So Saturday is here for you. Monday is here for you. Thursday is here for you. The other days, you're online. I'm doing the same work. Students online now, same thing. 5 days a week you have class now. If you have other classes, that is in the time of the class that we have it, because you have other classes to go into, then you have to make up for it in the night when you're at home. I was saying yesterday to the students in the class yesterday that no longer Can you be sleeping now 10 and 12 hours? You have to cut that time. No longer can you be wasting time watching video, watch one around us, so still watch video and laugh. You can't bother with that. Stop watch video and laugh. And listen to me. Stop watch video and laugh. Listen to me. Hey, listen to me. You're the first person to come check your result, you know. When the exam results come, you're the first person. Any part Jada Lewis, them you find her, you know. You try to make sure say one is straight A's upon the exam results, you know. In fact, me go message your father and find out this for you. Now, when exam results come out, Jada Lewis are the first person to look for. Because any old you get a grade 1, the pinch you ever get, your grandmother will feel it. You understand? Look here, man. This subject too easy. This subject is an easy subject. You just need to do certain things to make it easy. You have to be prepared to do the things that will make it easy. And I'm telling you the things that you need to do to make it easy. We have to make progress. We can't stuck at the same place. And the way you make the progress is to eliminate the mistakes that we've been making before. You can't be making the same mistakes going forward. We have to clear the misunderstandings that we have. Mathematics or mathematical principles can only be fully understood by doing one thing: solving many questions. That's how we gain full understanding in maths, by solving questions. Not watching somebody solve them. Not watching Sir solve them. Sir solving them is just give you a little guidance, put you in the right direction, clear up certain things for you. But for your own full understanding, you have to solve the question there. Not what Sir solved them. That's not good enough. You get me? So no one get the ones with straight A's. Me want to not get the ones with straight A's. The ones with straight A's, they're waiting for you to go and get it. You have to put in the work to get it. There's only 5 weeks left. So the most can make the sacrifice for 5 weeks. Cut down on the video watching, cut down on the movie watching, cut down on the TikToking, cut down on the YouTubing, cut down on the Instagram, cut down on them things there. Put more time in solving questions. I suppose you see the same approach for the other subjects, and I'm not telling about it. Same dedicated approach for the maths. Use the same strategic approach for that subject. Every subject have a strategy, approach that you use to gain success. You have to determine that best strategy for you in those subjects. I'm telling you the strategy that will work for sure in maths. It has worked forever and will work forever again to come. Without fail, all mathematical principles can only be fully understood by solving many questions. That is why we are doing between 24 and 28 mock exams. How much we got now? 8? We got 8 now. Whatever we got, we have them 4 now. So we are doing 4 more that week here. Wednesday and Thursday 2, Saturday 2 more. That's 4 we are doing that week here coming. Pass mark moving come Saturday. We have to move with the pass mark. You get me? So I want to know, commit to yourself to doing it. There's only 5 weeks left. You get me? Now get grade 1 preparation. We have to produce grade 1 results. You know, in a sense, you get grade 1 preparation and don't get grade 1 results. Jada, you know, in a sense, when your classmate get 1 with straight A's, the same class where you go. Oh, yeah. All right. I believe you, I believe you. I believe you. But you can't just talk and get it. You have to put in the work to get it. Just do what I tell you and you will get it. Just do what I tell you. Guys, just do what I tell you now and we'll get it. I'm talking to those in the class and those online. Put in the work and you will get the results. All right? So moving the pass mark on weekend. You have to move with the pass mark. Can't be stuck behind with the pass grade. You have to move with the pass mark by improving, eliminating the mistakes, clearing the misunderstandings. You do that by redoing the questions that they got wrong. Redo the questions that you got wrong. Redo the questions that you got wrong. Don't watch the video. Don't just watch the video alone. Don't just look at the solution. Literally do the questions that you get wrong. And if you still not understand, send me a message. And say, sir, I still not understand this. I'm going to do what I can do for help on the clear it up. Get me? Send me a message and say, sir, I try the question and I watch the video. I still not understand the part, sir. I still not understand this. I'm going to call you now. I'm going to do and go through it with you now. If I find a different way to explain it, I'll find a different way to explain it to you. Come on, every single one I'm going to get one straight A's. Not less than that is good enough in this program. Not less than that is good enough. All right. So remember, prepare yourself, mock exam. So you guys are going to be at home. You guys here are going to be at home Wednesday. So I'm going to send the paper in the group. If you're in another class and you can't do it, you're going to make some time and do it at the night. You're going to go home at the night, take a sleep, dedicate a 3-hour period at the night. You're going to wake up and do the paper, and then go back to sleep. And wake up and come to school. These are the things you have to do to get success. When I might want to go to university, these are the things that people in the university have to do. Because there are certain things they don't have the time in the day to do it. You have to do it at the night. It's only for 5 weeks. You're doing this. And I have a whole summer for sleepers and don't want watching the TikTok and Instagram or whatever. Nice summer. But for now, I could just deal with the work, school work. Just for this 5 weeks, just make the sacrifice, make the dedication, give the commitment for the next 5 weeks. Just put in the work. The results is there. Nothing sweeter than an exam result. We have one straight A's on it. I tell you, nothing sweeter than that. And I feel so happy when you get a result there. But you can't get the result just like that. You have to put in the work for it. It is there for the taking. It is there for the taking. So we can go and get it. All right, guys. So see you all on Wednesday and Thursday. All right? Okay. Bye, students online. See you on Wednesday and Thursday. Bye, Elizabeth.
Sir.
Bye. All right.
Sir.
Mr. Carr. Yes, ma'am.
Remember to look over the thing for me, please.
I've not forgotten. It's just that I was super busy at work today. I'm gonna do it, man. No rest.
Okay.
You in my lecture, you know. Like my past favorite student, you know.
Oh,
So, all right. Mr. Jonathan, you okay? Mr. Stair, Jonathan gone.
No.
Oh,
Yes,
you're there.
sir.
Oh, you're there. You're good?
Yes, sir.
You have to move the needle next exam, right? Next mock exam. You have to move the standard, yeah?
Yes, sir.
You have to improve. All right. Mr. Barnes?
Sir.
Mr. Kwame? You
Sir.
good?
Yes, sir.
All right. I put in the work. See?
Yes, sir.
All right. Mr. Merchant?
Yes, sir.
You good?
Yes, sir.
All right. Just do what I tell you. Yeah, all right. See?
Yes, sir.
All right. All right. I'm going to end the call now. Bye, Elizabeth.
bye, sir.
All right. So, yes, sir, I make grandma feel proud, right?
Yes, sir.
All right. Good. Bye, everybody. I'm going to end it now.